a problem like 22. So this is the case where, in my opinion, trial and error is efficient, and let me explain why. Okay, so you can rewrite the middle term, and I'll show you that method as well. But in this case, when you look, your leading coefficient and your constant, they're both prime numbers, right? So it limits the number of factors you'd have to test in your trial and error for reverse foiling. So I would do it this way. Now, what makes it even more appealing is that, or in this case, again, you only have to test just a couple possibilities. Now, when you look at it, you're looking at +1, -3, -1, +3, and then you're looking at +3, -1, -3, +1. So within 4 tries, you will find your solution. And so if we take our outer and inner products and test them, so here's -6m plus 1m is at -5m. So when you test, so we have our FOIL, right? The only two products, only two factors that give you 2m squared are 2m and m, so we know what our first term is. Our last term has to be a total product of -3, so those are the only 4 combinations, right? A +1 and a -3 or a -1 and +3 in one of those combinations. So we're going to test our outer plus inner products. Which of these give us a total sum of -5m? So here's 2m times the -3 is -6m plus 1m. Does that give us -5m? Yeah. So we have our answer. It actually wound up being the very first one that we tested. And now, the other way to look at this is to rewrite the middle term. Okay. Again, the nice thing with that method is it's never going to be wasted efforts. It'll always lead you directly to your solution. So if you use the rewrite the middle term method, you're going to take your leading coefficient times your constant. So 2 times a -3 is a -6. And what we're going to do is we're looking to find what 2 factors of -6 have a total sum that's equal to this middle term's coefficient. So what factors of -6 equal -5? -6 and a +1, right? So if we rewrite our middle term as -6m plus 1m, drop down the first and the last terms, and then factor by grouping. In this first pair of terms, we can remove a factor of 2m, leaving an m-3. In this second pair of terms, and this is where, again, some confusion sometimes occurs, is there's no common factors between these two second terms, the second group of terms. And you always factor out the sign. And so if there's no common factors, you're just going to put a 1. Use the 1 as a placeholder. This is the one time where a coefficient of 1 can be written as a placeholder. If you factor out a 1, you just get the terms themselves, so m-3. But what it allows you to see by using the +1 as a placeholder is you have this common binomial factor of m-3, and then the remaining factors form the terms of your second binomial. And you can see it's the same thing that we found up here. M-3 and 2m plus 1 are the 2 factors.